Ethereum is entering its privacy era, and Arbitrum, already one of the strongest L2 ecosystems, is meeting it with a design philosophy centered on builder freedom. Two major advances, in my opinion, are driving it: zero knowledge proving for Arbitrum chains, and fully homomorphic FHE, fully homomorphic encryption coming from the Fhenix ecosystem. Let's first start with ZK. Zero knowledge proofs, in case you're unaware, let you prove that something happened without revealing the underlying data, which is a simple idea, but really, truly, really hard engineering. Arbitrum has a multi-VM model. It runs both the EVM and a WASM runtime through Stylus, sharing the same state tree. So proving an Arbitrum block is more complex than proving a single VM like other chains. This year, Offchain Labs and Succinct, well, they hit a milestone that shows, in my opinion, what is now possible and what's coming down the road very soon. They proved EVM and Stylus Arbitrum blocks using Succinct's new SP1 Hypercube. Hypercube is a next generation ZK VM built on multilinear polynomials that can prove the majority of ETH blocks, of Ethereum blocks, in about 10 seconds. That performance by itself is really significant, and getting it to work for Arbitrum's multi-VM architecture required a custom implementation that can capture both execution environments in one proving flow. This outcome aligns with the philosophy behind the entire Arbitrum stack. We believe that it's your chain when you build an Arbitrum chain, and it's your rules. If you are running, let's say, a high throughput chain, proving every block may still be too heavy of a cost. But if your chain is smaller or it's security focused, you can opt into more frequent proving for faster settlement and tighter interoperability. Instead of one fixed model, Arbitrum gives builders building Arbitrum chains flexibility in how they incorporate ZK into their design. Now let's shift and talk a bit about FHE. Fully homomorphic encryption allows smart contracts to compute directly on encrypted data, while the chain only sees ciphertext. That is in itself a wild new idea, but it's not new. The theory's been around since the 1980s. But what this means is there's no on-chain decryption, no unintentional data leakage, and no need to trust off-chain computation. The Fhenix team is bringing an FHE-enabled environment to Arbitrum through their Coffee model, COFHE, get it, Coffee model. It combines client-side encryption, encrypted state, and an FHE engine that can evaluate homomorphic operations while keeping data opaque to the chain itself. As a builder, as a developer, you write your familiar contract logic using your tools you already know, using encrypted types where you need them. The framework will manage for you the key workflows, the encryption of flows, and the heavy computation behind all of that homomorphic evaluation. Users can submit private inputs, receive encrypted outputs, and decrypt only what they choose. The result of all of this is a path toward end-to-end data privacy with on-chain verifiability built in a way that developers can start experimenting with not tomorrow, not next week, not any month from now, but actually today, like right now. This, in my opinion, opens the door for practical use cases: private auctions and bids, credit scoring without exposing user data, maybe on-chain games or games that use on-chain aspects where the logic cannot be reverse engineered. Any workflow, basically, where privacy and verifiability need to coexist together. Now, taking these two things, ZK proving and FHE, they mark a real turning point in how privacy will function across the Arbitrum stack. ZK strengthens verifiability and cross-chain trust. FHE shields user data at the computation level. For builders, this creates new design spaces when constructing Arbitrum chains. For users, it signals a world where privacy does not require giving up the benefits of open systems. The next wave of the builder experience is not only arriving, it's already here. And privacy is very much a part of it.